Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and welcome back to our video channel. Thanks so much for joining us for another video where we're going to be covering a cost optimization technique in the Amazon Web Services cloud platform. Before we get started with the topic, I wanted to briefly talk about StratusGrid. So StratusGrid is an AWS Premier Consulting partner. Also, we are an independent software vendor, or ISV, and we have a software as a service or SaaS tool called Stratusphere. And what Stratusphere essentially allows you to do is to identify cost savings opportunities across your entire cloud environment and then track the savings that you implement over time so you can see your efficiency operating score inside of your cloud environments. So if you're interested in seeing a demo of Stratusphere, head out to our website at stratusgrid.com. You can check out our product tab right here, which has some more information, including our knowledge base that has a bunch of articles that talk about cost optimization techniques and how to onboard to Stratusphere. And we would love to work you through that process if you are interested. So feel free to check out our website. Again, that's stratusgrid.com. Now, the topic I wanted to cover in this particular video is how to identify NAT gateways that are idle inside of your environment. And we're going to take a look at a little bit more of a manual approach to accomplishing this, but you can also identify idle NAT gateways using Stratusphere itself. So if you do have Stratusphere onboarded already, then you can go out to the Stratusphere console here, and you can go to what's called the findings view. And this is basically a resource by resource line item listing of all of the potential savings that you have across your entire environment. And what you can do is filter for specific types of findings, and we are adding more types of findings in the near future as well. So one of those findings is called the inactive NAT gateway. So you can see that right here in this list. So if we just check that option off, and then we make sure that we set our detection date range to somewhere between the date range where that would have been detected, then you can see that we have inactive NAT gateways showing up here. We can see the specific resource ID, also known as the Amazon resource name. These are just demo accounts, so that's why we have a GUID instead of the 12-digit AWS account ID, but these would be the actual ARNs of the NAT gateways inside of your environment. And then what you can do is go out to the AWS Management Console and actually take a look at those and delete the inactive NAT gateways, and that'll save you a pretty significant amount of spend, especially if you have multiple NAT gateways like we have here. Looks like there's about 177 different ones inside of this environment, according to this demo data. So that could add up to a pretty significant amount of spend. Now, if we go out to the AWS pricing page, so let's do AWS pricing for NAT gateways. The NAT gateways can cost anywhere from about $25 to $60, kind of depends on which region you're talking about. But if you scroll down in the VPC pricing documentation here and take a look at the NAT gateway resource type, you can see that in the US East 2 Ohio region here, it's 4.5 cents per hour. So if we do a little bit of simple math right here and say, let's do 0.045 times 720 hours in a month, that's about $32.40 per month for a NAT gateway in the Ohio region. However, if we choose a different region, for example, let's go to South America, to the Sao Paulo region here, you can see the cost goes up to 9.3 cents per hour, and some other regions may be more expensive as well. So feel free to check out the costs for your different regions. Here, Africa, Cape Town is 5.7 cents. So if we use, let's say, 0.093 times 720, that's about 67 US dollars per month for the Sao Paulo region in South America. So as you can see, they generally range around 25 to 60, maybe even up to $70 per month for a NAT gateway. So if you're not actively utilizing those NAT gateways, then you want to go ahead and remove those from your environment so that you're not wasting that cloud spend on a resource that you're not actually getting any business value from. So again, the easiest way to identify these is to simply onboard to Stratusphere, and then this will report a list of your inactive NAT gateways to you. Or we're going to take a look at how you can do this on a little bit more of a manual basis inside of the AWS Management Console. I did want to point out that there is some documentation here for the AWS Virtual Private Cloud Service. If you check out Connect Your VPC, NAT Devices, and then NAT Gateways, there is a section down here called CloudWatch Metrics that actually talks about the different metrics that are available. And these are native metrics to the NAT Gateway service. So when you provision a NAT Gateway, these metrics are automatically sent to the Amazon CloudWatch Metrics service. And so these metrics will be available inside of your account so that you can analyze the utilization level of that NAT Gateway and manually determine if it is active or inactive over a given period of time. So that's what we're going to look at how to do rather than using the automated mechanism inside of Stratusphere that will save you a lot more time across your entire environment. So what we're going to do is go into our AWS Management Console here, and we're going to set up kind of a mock scenario with a VPC that has public and private subnets. We're going to set up a NAT gateway in one of the public subnets. If we go back to the documentation here, they actually have under NAT instances. NAT instance is basically a self-managed gateway, but this little diagram here at least kind of shows the conceptual architecture. But what we're going to do is have an EC2 instance sitting in a private subnet, and we're going to have a NAT gateway, a managed NAT gateway, not a NAT instance, sitting in a public subnet. And that NAT instance is then going to allow network traffic to route through the internet gateway that is bound to the VPC. So we have to make sure our route tables are set up for this private subnet down here so that any traffic that's destined for the internet is going to get sent to the NAT gateway once we provision it. So that's kind of how the NAT gateway works. What we're going to do is set up an EC2 instance in a private subnet, and we're going to connect it to a service called the AWS Systems Manager service using Session Manager so that we can actually remotely access that without having direct SSH access to it across the internet. So we'll be able to SSH into it effectively, getting a shell in our browser, and then we'll be able to manage that EC2 instance and invoke some network traffic through the NAT gateway. And what that's going to allow us to do is to actually see some interesting data in the metrics in CloudWatch for that NAT gateway so we can see what data we are actually interested in looking at when it comes to the built-in or native metrics to the NAT gateway feature in the VPC service. All right, so I've already got a VPC right here set up, and if you want to set up your own, you can just go to the VPC dashboard and then say create VPC. You can choose VPC and more. You can disable the VPC endpoints. You don't need those down there, but then you can say, all right, I want a NAT gateway and 2 private subnets, 2 public subnets, and that'll set up everything for you automatically here. I've already got a VPC where I have private and public subnets set up and my route tables are all set up already, but I don't have a NAT gateway because I don't want to be wasting that money on it. So we're going to go ahead and just add a NAT gateway and then reconfigure our route tables to point to that NAT gateway, and then we'll provision the EC2 instance in the private subnet. So if you check out the VPC ID right here, it is 041D. So if we go to subnets, we want to filter to subnets that belong to the VPC 041D. And so here's a list of all my subnets. So I've got some IPv6 only subnets here. I have some public subnets with traditional IPv4 access on them. I also have a couple of private subnets here as well. So what we want to do is provision a NAT gateway into one of the public subnets and then set up the route table for these private subnets here to route network traffic destined for the internet at large through that NAT gateway. One of the things that you'll need is an elastic IP for the NAT gateway. So I'm going to go ahead and allocate an elastic IP right here. And I'll just plug in the owner tag right here so that my teammates in my dev account know who is creating that. We'll go ahead and allocate that. And then we'll go to NAT gateways here. We'll say create a NAT gateway. And then I'll say Trevor01 StratusGrid. Let's choose one of my public subnets here. So let's see, I've got private subnets in US West 2A, it looks like. So I'm going to go ahead and choose US West 2A so I keep everything in the same local availability zone here. It's going to be public, and then it's going to have the elastic IP that we just allocated. And then I will also add the owner tag to this NAT gateway in addition to the elastic IP itself. All right, so that is currently provisioning right there. Now, what we want to do next is to set up our route tables. So the NAT gateway already has an ID, even though it's in the provisioning state, it already has an ID associated with it from the control plane. So we'll go down to my route tables right here. We'll go to the route table for my US West 2A availability zone here. We'll go down to routes. And then what you'll see down here is that I've got this black hole route down here. And so I want to basically edit that black hole route that goes out to the internet to point to the new NAT gateway, because this NAT gateway ID that we have right here, this is the old NAT gateway that I had previously provisioned for this VPC. So we'll go ahead and choose to route to a NAT gateway. We'll go ahead and choose the one and only NAT gateway ID right there. Then we'll go ahead and save those changes. I'll do the same thing for the other private subnet, just in case for some reason we want to use that subnet as well. I don't think I'll end up using it, but we'll go ahead and just update that destination ID of that NAT gateway right there, and now we are good to go. All right, so now we've got our VPC set up, our route table set up, we got the NAT gateway with its elastic IP and everything, and so now we're going to go over to the EC2 service and launch an EC2 instance. So I'm going to say launch an instance. I'm just going to call this Trevor01 VPC NAT testing. And then we're going to choose the Ubuntu image here. For my instance type, I'll choose something like a C6, maybe a C7A. Let's try that. Let's try C7. My keyboard input is kind of hanging up right here a little bit. Sometimes the AWS Management Console can be a little bit on the slow side here. So we'll say C7A. Let's do a large here. And then I am going to assign a key pair just in case I need to SSH into it from somewhere else. I don't anticipate needing that. Then I'm going to choose my VPC, and I'm going to choose the private subnet in the US West 2A availability zone right there. We're not going to assign a IPv4 address. I can assign an IPv6 address to it. That's fine. We'll do select an existing security group, and I'll go ahead and just assign this one and default for now. And then for the storage size, I'm going to bump up the storage a little bit because I'm going to be downloading some content through the NAT gateway onto the local file system. So I'll just bump it up to, let's say, maybe 60 gigabytes here. And then under my advanced details, I am going to choose to use a spot instance here. And I'll say persistent. And if it's interrupted, just stop it. And then for the permissions to register with the Systems Manager service so that I can use Session Manager, I have an IAM instance profile, which is basically just an IAM role. It's called Trevor Dev Server here. And this has the SSM Managed Instance Core policy associated with it. So you can go over to the IAM service and just create an EC2 role and then bind the SSM Managed Instance Core policy to that role, and that will allow your EC2 instance to register itself with the Systems Manager service, and then you can access that EC2 instance on the private subnet, even though it's not routable directly across the internet. The agent that's running on that server is actually talking out to the Systems Manager APIs, and that allows us to then connect to it from the AWS Management Console using Session Manager, which is a feature of the AWS Systems Manager service. So now what I can do is head over to, let's say, Systems Manager right here, and you can kind of monitor to make sure it gets registered as under the fleet configuration. So let's go to Fleet Manager right here, and we should see that instance register itself pretty quickly here. So yeah, sure enough, here it is right here. It's got the system name right there, VPC NAT testing. So what I can do, and you can do this from the EC2 console as well, you don't have to do it from Session Manager, but I can choose node actions over here and then say connect and say start a terminal session. And that will allow me to get a interactive shell on the remote server, even though it's on a private subnet. So now all the network traffic that's going to and from the internet is going through that NAT gateway resource that we provisioned. So I'm going to do sudo su Ubuntu here so I can run as the Ubuntu user. It normally logs you in as a system user, so I'm just going to use the Ubuntu user here. And then I am going to download the Olama container image. And the reason I'm going to do that is because Olama has some really large images for LLMs, large language models, and that's just going to kind of serve as a mechanism for me to download some very large content to this server. So I'm going to do a sudo apt update, sudo apt-get install docker.io. And then once we've got the Docker engine installed, we'll go ahead and download the Ollama container image and run an Ollama container from that image. And then we'll just download one of the images from Ollama. So if we go to the Ollama model registry over here, let's go check out models. There's a whole bunch of different models. There's this new DeepSeek thing. I haven't tried that yet. There's the Llama 3.3 right here. So, we could download this. This is a 43 gigabyte model right here. So this might be a good one to download. So it's the Llama 3.1 70 billion. I'm not sure why it says 3.1 because it's actually 3.3, but we'll just go with it anyway. So we could go ahead and download that one. And we could look at some other models here as well. There's some much larger models. There's some smaller models. But basically, we're just going to download one of these large models to chew up some bandwidth so we have some interesting data to look at on the NAT gateway itself. Okay, so back over here in our shell, we're going to say sudo docker pull, I think it's Ollama from the Docker Hub. Pretty sure that's the correct image here. Yep. So that's kind of a large image there. It'll take just a second to download that last image layer. And then once we do that, we'll go ahead and just run a container from that, and then we'll initiate a pull operation on one of those large Ollama models from the model registry. And then while that's downloading, if we switch back over to the AWS Management Console right here and go to the CloudWatch service, we're going to take a look at the metrics available on the NAT gateway. Remember, in the documentation here for the VPC service, we've got all these metrics that are available out of the box for the NAT gateway. So we might want to look at something like bytes in from source, or active connection count, or bytes out to source, or connection attempt count. I mean, there's a lot of useful metrics here. Packets in from destination, so you can look at the number of packets versus the number of bytes total. It's really up to you which metric you want to look at. There's a lot of useful metrics here that can kind of give you a good indication of if there is any kind of activity on that NAT gateway or not, right? So what we'll do is go out to the CloudWatch service. We'll go to all metrics. Let me minimize that sidebar right there. And then we are going to be looking for the NAT gateway. So here's the NAT gateway namespace right here. And then we're going to go to NAT gateway metrics. And if you have a lot of different NAT gateways, you are going to see a huge list of NAT gateways and all the corresponding metrics here. So there might be a lot of line items. In this particular case, I only have one NAT gateway in the Oregon region here. So thankfully, I don't have to sort through all those. But if you know what the NAT gateway ID is, you can actually just paste that into the search right here. And that will filter the list of metrics to just that particular NAT gateway that you are looking to monitor. So for example, I like to use bytes. So if we look at maybe bytes per second, where did I see that? So we've got bytes in from source, bytes out to source, bytes in and to destination. And then we've got peak bytes per second right here. We've got active connection count. So what I'm going to do is go over to graphed metrics here. And because these are two different metrics, right? So one is going to be bytes per second, the other is active connections, and these are on two totally different scales, right? So when you look at bytes per second, you're probably looking in the millions or hundreds of millions of bytes per second of download speed coming from the Ollama model registry, or even just downloading the Ollama container image from the Docker Hub like we just did. So that's on a totally different scale than the active connection count. When it comes to active connection count, my EC2 instance might have, I don't know, 10, 20, 30, 40 connections out to various services like Docker Hub and the apt-get repositories for the Ubuntu operating system or things of that nature. So we're operating on totally different scales here. And as you can see in the graph right up here, we have, 0 to 1.4 million. And so that's not particularly helpful because our connection count right here is 44 and our peak bytes per second is 1.5 million. So what you can do to make this a little bit more visualizable is to change the y-axis for one of these. It doesn't matter which one, but I'm just going to put the y-axis on the right side for one of these metrics, and then the other metric can continue to use the axis on the left-hand side. So now we have something that's a little bit more meaningful here. It looks like these data points are actually stacked right on top of each other, which is a little bit weird, but that's just kind of coincidental based on the scale here. So something else that we could do is to actually tweak the scale. So for the right y-axis, we could say the scale's from, how about 0 connections up to 80 connections. And so now we've got a little bit of visual separation right there. So now we can see those two different metrics. So the blue one is bytes per second. That corresponds to the left-hand y-axis. And the orange one here is active connection count, which corresponds to the right axis over here. So now we have each of those metrics to scale, and we can start to see that there is some activity going on here. One of the other things that you might want to do is to change the time period. By default, the time period is 5 minutes down here. I believe they might have 1 minute metrics as well. So I'm actually going to bump this down to the last hour, actually even less than that. Let's go down to 30 minutes worth of data. And we're going to change the period on both of these down to 1 minute. And now you can start to see a little bit more interesting data here. So we've got 2059 UTC, 21 UTC, 2101 UTC. So yeah, we've got per minute metrics there that allows us to see a much more granular scale of what's happening here. And on the connection count side, you can see we've got, 40 connections, then it kind of drops off down to 19 connections and so on and so forth. The other thing you can do is to set auto refresh up here. So we'll just set auto refresh every 10 seconds, and that will automatically update this graph with the latest data. And you can even bump this down to something like the last 15 minutes just to get a little bit more utilization out of your screen real estate here as we're looking at this data. All right, so now that we've got our CloudWatch graph configured, I'm also just going to rename this to NAT Gateway metrics here. And by the way, you can add other metrics as well. Back under the Browse tab right here, we saw there's lots of other useful metrics. So if you'd rather not use peak bytes per second or active connection count or anything like that, feel free to check out some of these other ones around, packet counts or byte counts, inbound and outbound, and so on and so forth. But these two are pretty useful for the time being. All right, so as you can see, over the last couple of minutes here, our connection count has dropped way down. The bytes per second has dropped down to almost 0. Of course, we do have a little bit of network traffic there just because we're using Systems Manager to connect to the instance. So the Systems Manager agent has to communicate with the Systems Manager APIs out on the internet in order to utilize that functionality. So it's not quite 0, but the bytes per second is very, very close to 0. All right, so if we go back over to our console right here, you can see things have kind of calmed down. We do still have some active connections just because there's background services running on this server. But what we're going to do is go ahead and do docker run -rm-it to make it interactive. The -rm here is going to delete the container after we exit the container entry point. And then we're going to specify olama/olama. And of course, I need to do sudo there because my Ubuntu user is not in the necessary Docker group. So we'll just do sudo. And so by default, it's going to launch the service right here and just kind of hang. So let me just do Control-C on that. And then I'm just going to run bash. Actually, let me change the entry point to bash right here. And so rather than running the service, we're just going to get a bash shell. And so then what I can do is say olama, and then I can say olama pull, and then specify one of the images that I want to download. So in this case, we're just going to grab llama 3.3, and we do actually need to be running the service as well. So what I'm going to do here is say docker run, and we're going to remove the entry point, and we're also going to add the detach here. Okay, so then if we do docker logs 32e2 with sudo, you can see our service is up and running here. Then what we want to do is do a docker exec into this container image and run bash inside of there. So we'll say sudo docker exec -it to make it interactive, 32 e2, and then bash. And now we have a bash shell. And now we should be able to use Ollama to pull llama 3.3. And as you can see, it's downloading that 42/43 gigabyte image. And you can see it's using a lot of bandwidth here, about 200 to 300 megabytes per second. So it's downloading that massive image to the local file system. So that's going to generate a lot of network traffic and show us a lot of interesting data inside of our CloudWatch metrics. Now you could use plenty of other mechanisms. You could use like an automated web request out to some website if you'd like to, but this is just kind of a simple network stress test that I like to use just in case I want to download a whole bunch of network data. Okay, so if we switch back over to the CloudWatch console right here, the metrics are slightly delayed here a little bit. So we've got our auto refresh set at 10 seconds right here. And after a little bit here, you're eventually going to see that the bytes per second is going to spike way, way up. So 30 million would be 30 megabytes per second approximately, and so on and so forth. So we're going to see this scale on the left-hand side shoot up straight up, and it's going to be consuming a whole lot of bandwidth in the range of around 300 megabytes per second at the peak. So we'll just go ahead and let that run for a second right here. Looks like it kind of leveled off down to about 130 megabytes per second, which is totally fine. And so eventually we should see those metrics pop up over in the CloudWatch console. So it's refreshing here. We'll let it go a little bit longer. There is sometimes like a 1 to 2 minute delay on actually getting these metrics from the service here. So let me just pause really quick and we'll come right back. All right, so as you can see, our CloudWatch metrics have spiked way, way up here. You can see that we've got peak bytes per second up here in the 80s of megabytes per second. I would have expected it to go a little bit higher than that, but we might just be delayed on some data points. Of course, that is a peak bytes per second. So yeah, I think I would expect that to be spiking up a little bit higher. So maybe we're just a little bit delayed here, but you get the idea. We are generating some network traffic. Also, our connection count has gone down from 17 all the way up to 35. So we definitely have a lot more TCP connections being created out to external services through the NAT gateway that we are monitoring using the Amazon CloudWatch console here. Now, if we cut off this process, if we just do a Control-C to abort that, and we exit that container, and we close down the console there, and then finally, we get rid of our workload entirely, right? So we're going to completely eliminate our workload by going to my persistent spot request. We're going to right-click on that persistent spot request and then say cancel request and confirm that. So we have terminated any workload that's running inside of this VPC on a private subnet. And so there is not going to be any more traffic going through that NAT gateway. That is going to be completely idle. There aren't any TCP connections being created. There's no data being passed inbound or outbound from that NAT gateway. And so what's going to happen is we're going to see these metrics that we saw peaking before when we had some actual work happening, some actual network workload happening. These metrics are going to spike back down to essentially zero. So there should be zero connections, zero TCP connections. There should be 0 bytes of data going inbound and outbound to the NAT gateway here. And that is how we will ultimately identify an idle NAT gateway on a manual basis. So what you can do if you have an extended period of time here, let's say maybe over the last week of time, we could say, all right, I want to look at the last week of metrics here, right? And if this NAT gateway has been sitting out here for a week or more, then we're going to see a chart here that shows all of the metrics across that entire week's period of time. And so that's going to show me, has this thing been sitting idle for an entire week? Are there certain days over the last week where that NAT gateway has been active a little bit and maybe sending some data back and forth, which could give you an indication of a kind of temporal workload? It could be a Lambda function that's connected to your VPC. It could be a container-based workload running in an AWS Fargate, for example. It could be an EC2 instance that was spun up for 10 minutes and did a little bit of work and then shut back down and terminated itself. There's a whole lot of different scenarios where you might have temporal workloads, but by configuring your CloudWatch chart correctly, you can actually see all of the historical data for that particular NAT gateway. Now, obviously, because this is a demo environment that I'm setting up here, I am working on a much more narrow timeline here. So I'm more interested in the 15-minute chart than I am in a 1 week or 2 week or even a 1 month chart to really analyze in depth if this NAT gateway is needed or not. So as you can see, what's happening here is the metrics are dropping back down after we canceled the execution of that Olama container on that EC2 instance and then finally terminated the instance. Also, we're going to see the connection count drop off pretty severely here as well. And then once that drops off, we know that that NAT gateway is now going to be idle. So let's give these metrics another minute or two to update after the deletion of that instance. And we can also come over here to the EC2 console and just double check that that has actually been terminated. And sure enough, it looks like it has been terminated. So I'm just going to give this a minute to update, and we should see these active connection count metrics and peak bytes per second metrics drop off to 0. All right, so after a minute here, you can see that the connection count has dropped way off. We are still seeing an active connection count of 1, but I would anticipate that that's perhaps just a leftover connection from the NAT gateway itself. But if you take a look at the peak bytes per second metric, that has dropped off completely down to 0 for the last several minutes. Now, one potential reason that you might see this active connection count showing as 1 is because if you take a look at our graphed metrics, the statistic is an average here over the course of that minute. So if we change the active connection count to a sum metric, that should show us the actual figures of how many connections were detected during that minute. So you can see it looks like previously there were 2 connections. Now it has dropped off to 1 connection. And eventually I would expect that that would drop off to 0. So if you see that this line here is static for a long period of time, then that probably means that there are no new connections being created through the NAT gateway from any kind of workload. Again, it could be a Lambda function, it could be a Fargate container, it could be an EC2 instance. There's lots of different resources that could potentially be creating connections through that NAT gateway. So just keep an eye on these metrics here or any of the other metrics that are available inside of the console here. And this will help you to determine if that NAT gateway is actually doing something, as we can see in this period right here, or if it has leveled off and there is no actual network traffic passing through that NAT gateway. But again, the easiest way to identify these idle NAT gateways is to simply onboard to Stratusphere, and this will allow you to easily identify which AWS accounts, which AWS regions those idle NAT gateways are residing in, and the specific resource ID of those instances so that you can go out and delete those NAT gateways and ultimately achieve a cost savings inside of your account. One of the unique features we have here in Stratusphere is the ability to set a status. So once I remediate one of these items, I can just come in here and say that I have resolved this and say, hey, I deleted this NAT gateway last week. And now that particular item has been resolved. And if I want to report on what I've actually implemented in savings, I can now go to the status filter right here and then filter to the resolved items. And that's ultimately going to tell me which items have been resolved and give me a summary of all of the implemented savings. So let's go to status, choose resolved right here. And you can see that this particularly expensive NAT gateway here, $37,000 a month. Of course, that's just some demo data. You can see my comment right here as well, but because that item has been resolved, it's showing up in this summary view. And this works for all the other types of findings as well inside of the Stratusphere console. So this helps you to kind of keep track of which things you've implemented or which things maybe you've deferred to the future. If you decide that you want to just accept this as a temporary risk, you can say, hey, I'm going to bump this out to February 28th, and feel free to remind me after that. And I'll just say defer this to the future. And that's another option you have as well, is to just accept it as a known risk. And you can also filter on those items by just going to the accepted filter right here. And if there's any items that you've accepted as a known financial risk, you can see those in this list and always update them here if you decide later on that you're actually going to take action on those items. So in any case, I hope that this video has been informative for you. Don't forget to delete your NAT gateways in your demo environment if you've been following along with what we've been doing over here in the AWS console. We don't want to waste any unnecessary spend in our cloud environments. Please leave a like down below, leave a comment, let us know what you thought of this video. Also, make sure to check out all the other videos on our channel. We've got lots of great, interesting cloud content, so feel free to check those out and subscribe to the channel to get notified about future videos as well. Again, I'm Trevor Sullivan, a solutions architect with StratusGrid. Thanks for watching, and we'll see you in the next video. Take care.